Docker architecture and its taxonomy. In this particular session, I am going to introduce a lot of new terms. And most importantly, we are going to relate all these terms together, which practically we are going to look at from the next session. So yes, this session is going to be all theory, wherein we will invest our time in understanding how does actually Docker works. A very high level overview is what I am going to provide over here. So for Docker as a platform, remember the core is a Docker engine. Now what is Docker engine? Docker engine is a client server application. And this client server application is supposed to have three components. A server component, which is going to have a daemon process, the one which is going to run forever. Long running process is what we call it as a daemon process. And then it is going to have a client component, the command line interface application, which is actually the one which we use for communicating with daemon. So a client is actually a CLI client here, command line interface client. And this CLI client, the instructions in CLI client, the commandlets of the CLI client internally are going to get converted into REST API calls. So the REST API, which specifies interface that program can use to talk to the daemon and instruct what the daemon should do. So I repeat, a Docker engine is supposed to be a software which we have to install on top of our operating system. It is a client server application wherein the server is a daemon process, a client is a CLI client, and the CLI client internally uses the REST API to send instructions to the daemon to perform certain action. So what is a daemon? What is a CLI client? See this particular diagram. It gives you much better picture. A CLI client is an application which will execute instructions like this: Docker build, Docker pull, Docker run, and many more such commands are part of CLI client. These CLI client instructions internally are converted into REST APIs and transported over a socket to a Docker daemon. The Docker daemon takes those instructions and is then responsible for managing these images, containers, and of course it is also responsible for managing the network and volumes, which are actually storage. And of course Docker daemon, wherever needed, can also communicate with a Docker registry. Where is Docker registry? It can be either on the same machine where we have the daemon, or it can be on the same network, or it can be even on internet, a global registry. So these are the three things which are going to have very important role in building clients, building containerized application: Docker client, Docker host, and Docker registry. So what is a Docker daemon? Docker daemon, which is also referred as Dockered, listens for the Docker API request and manages the Docker objects. Now what are the Docker objects? Images, containers, networks, and volumes. These are the most popular Docker objects. We actually have few more, but these are the most popular ones. These are the most common ones, which are used very frequently. Docker daemon, if needed, can also communicate with other daemons on the network. It is pretty much possible. And what is also important is the Docker client and Docker daemon can be on same machine, and they may not be on same machine. They can be on different machines on the network. Pretty much possible. So what is Docker client? Is a primary way that many Docker users interact with Docker. So if I want to use Docker, I'm going to actually use Docker client commands. What will be commands? As I told earlier, it can be something like this. Docker run is one command which is actually responsible for creating an instance of an image to create a container. So Docker run command, when I give it to the client will internally convert that into the REST API call, send the instruction to the daemon. Daemon would then be responsible for creating a instance from an image. And of course, if the image is not available, it will download from a Docker registry. A Docker client and daemon can run on the same system, or you can connect Docker client to a remote Docker daemon also. They communicate using REST API, and of course internally it is the socket and the network interface which is used. Docker client can communicate with more than one daemon if needed. We have to specify the daemon name in the instructions, and we can communicate with more than one daemon also. So how does the whole system works? See, in a Docker application, Docker containerized application, we are going to build our normal, let us say, .NET Core application. And for this .NET Core application to be containerized, the first thing we will have to do is write a Docker file. Docker file is a set of instructions which are supposed to execute for creating images. So there will be one base image. On top of the base image, there are layers of images created, which I am going to explain more in detail later. But yes, we are going to have an image layer created with one primary image for our application. These images are saved persistently on our disk. Docker daemon creates the image and saves them on the disk. And on need basis, it can load those images from the disk. But there are cases where when the image which we require for execution is not found on the disk, in such cases, the image will be pulled from Docker registry. So yes, we also have Docker commands through which we can push the image into the Docker registry. Where is Docker registry? It is basically maintained by Docker organization. A public registry is maintained into which we can push our images. So I provide a Docker command to a Docker client along with the Docker file for creating an image. Image is then saved in the Docker in the same machine in a persistent disk. And then I give a separate command to create a container from a Docker image. Think of Docker image like a class. And for that one class, can we have multiple objects? Think of every object like a container. So from one image, we can create now multiple containers. And every container is completely isolated from the other containers. It runs independently. And if there is a network, that container will have its own file system. The container is going to have its own IP address. And these containers we can always start, we can stop when we don't need them, and then of course we can restart. We can peek into the container and see what is the current state of the container, and if required, from the current state of the container we can commit and create a new image. And of course thereafter that image can be used for creating more instances of that committed state of the container. So most of the time it is the images which are instantiated as container, but a particular state of the container can be saved as image if needed, so that we can always create multiple instances from that particular state of the image. So yes, ultimately it is the container which is going to execute on our machine. The runtime instance is called as a container. That's why I'm calling this as an object. So let us see these things a little more in detail. What is a Docker container? A container is a package with all of its dependencies. Everything what is required for execution of the application is all part of that container. And the information which is required to needed to the creation of container is also part of the container image. Sorry, this is image actually. Docker images are ideally referred as Docker container images, but most of the time in short we call it as just image. Docker image, just to avoid the terminology, I'll call it as Docker image. and Docker containers. So Docker image is the one which contains the primary application along with all its dependencies. An image includes the dependencies such as whatever is the framework. Suppose we are doing a .NET application. The .NET framework would be part of that image. If I am doing Java application, Java runtime would be part of that particular image. Plus the deployment and configuration to be used by the container runtime. Usually the image derives from multiple base images. Remember, we are going to have multiple images created, and through those images, layers will be stacked one upon the other to create a new container. An image is immutable after it has been created. Of course, once the image is created, we cannot change that image. We can use that as a base image and on top of it create one more image. But that original image which is created, you can either use it for creating the instance or you completely destroy. But once created, it cannot be edited, it cannot be modified. Docker images can run natively on Linux and Windows. See, one of the big misconception is Docker is going to make your application platform independent. No, big no. Docker will never make any application platform independent. What does it mean? Whenever I'm going to create a Docker image, the image is always supposed to be for a specific operating system. So if I want to run my application on Windows, I'm going to create a Windows image. Likewise, if I want to run image on Linux, I'm going to create a Linux image. So once the image is created for a particular type of host, that image can be used for creating the instance, which is a container, only on that particular operating system. It cannot be interoperated. So yes, the images for Windows will be different and the images for Linux will be different, and they are not interoperable. But then when we see Docker for Windows operating system, see, Docker for Windows operating system has little extra advantage. Docker for Windows operating system has an ability to behave at times as Windows host or Linux host at other times. For example, on my machine, I already have Docker for Windows installed. Just type first Docker space version and you'll see that there is a client, Docker client, and there is a Docker server, the daemon. And the Docker daemon is right now using Windows operating system. Client is Windows, no doubt, but the daemon is also Windows operating system. Now in the system tray, we are going to have a Docker icon, which when we click, we can switch. So right now it is Docker for Windows. I'm switching to Linux containers. Click on that, it switches. And once it is switched, it will take a couple of minutes. Once it is switched, you again execute the same Docker version and you'll see this time it is going to give Linux for this instead of Windows. See, right now the server is not yet running because it has to start completely. It will take a couple of minutes, as I said. Let's try once again. Still not ready. Now let's try once again. Docker version. Yes, now you see it is Linux. So actually what the Docker for Windows operating system does is, it uses the underlying host, the actual Windows operating system, when it is configured for Windows containers. But when I switch to Linux containers like it is right now, it internally uses a virtual machine. Docker for Windows creates a virtual machine for Linux and it internally uses that. So in Windows specifically, this facility is not there in Linux version of the Docker. In Windows specifically, we have an ability to create images for Linux or for Windows by using the switch to switch between the two different types of environment. But remember, A Docker image which is created for Windows will not work on Linux, and Linux image will not work on Windows, even though we might use Docker for Windows. We have to switch them properly. And now something very, very important, containers. Let's talk about it in the next video. Thank you.